Hello. Hey, Alex, how are you? We're gonna let some people collect here over the next couple minutes. But feel free to unmute your microphone and introduce yourself. This isn't a webinar. This is like a place where you can talk to people and get to know everybody. So feel free to turn on your video and unmute your mic.
Hey, good evening.
Hey.
Good morning.
Great to have you here. So where are you calling
Likewise.
from?
I'm in the Netherlands, in the south of Holland. Yeah.
Cool. And so what do you work on?
I'm a machine learning engineer at ZenML. So yeah.
Cool.
Are you all working at DVC? I presume you all know each other.
Yes.
Should we do some quick? We can do some quick intros while we wait for people to trickle in, I guess. Yeah. Hi, I'm Dave. I'm the technical product manager for DVC.
Hey, Chris, how are you? Hey, Brahman, great to have you here.
Hello. Very good. How are you?
Oh, you're in like a quiet room. Cool.
Yes. I'm in an office now, so I need to isolate myself when I talk to other people.
Nice. How's that going back in the office?
Yeah, it's going pretty well. I think we moved since over the pandemic, so everything is new. That's quite nice.
Cool.
Yeah.
So how's your week going?
Good. We're actually doing a lot of DVC work at the moment.
Good.
Yeah. We're integrating it into our main repositories.
Awesome.
Yeah, so it's kind of been a recent thing for PaperCup.
Good to hear. Cool.
Yeah.
So yeah, Alex is new here. He's in the Netherlands. So he's joining us today. We're just letting a few more people trickle in before we get started. Joe, how are you doing?
Hey, good morning, everybody.
All right, well, it's 8:03, so let's get started, and I'll keep letting people in as we go. But today we have our developer advocate, Milecia McGregor, presenting using DVC experiments in transfer learning. This is a presentation based on her blog piece, which I will put into the chat. She's been presenting at lots of conferences, and today she's here to share the material with us. I'll let her give more background on herself and get started. Off to you, Milecia.
All right. So, hey, everybody. Like Jenny said, my name is Milecia, and I'm the developer advocate right now. Just going to throw this little plug out there. If any of y'all are interested in developer advocacy for DVC, you can apply. We have a posting for that. But anyways, so I'm going to share my screen. One thing I do want to kind of stress is that this is super informal, so you can feel free to interrupt me at any time. Like, I don't mind questions. I really hope that y'all have questions. But today we're going to talk about using experiments for transfer learning. And if you aren't already following us on Twitter, go ahead and follow us at DVC.org. So what is transfer learning, right? In a nutshell, it's basically taking an existing model and modifying it for a different problem. So maybe you have a really good model and you just want to update the head on that model to classify or work on different problems. But this is a pretty good image to sum up what it does. So with a traditional machine learning model, you're making the model from scratch every time. You don't actually get to save any of that knowledge from other like experiments or other instances this model has been used. But with transfer learning, you can take all of that built-in knowledge in the model and apply it to something else. So maybe your training time will be shorter. You might get higher accuracy, things like that. So are y'all pretty familiar with transfer learning? I think it's a pretty common thing that we do. So now I'm just gonna jump straight into demo. Back over here, we're gonna talk about our pre-trained model a little bit. So this is just a little CNN that classifies some bees and ants. Nothing too crazy. Oh. Sorry if y'all heard the car. Some people are being crazy on the street. But anyways, we have this little model here. We have a train and validation phase, and it's recording some metrics like our accuracy, the loss, the training time, things like that. But the pre-trained models that we're going to be working with are Alexnet and SqueezeNet. And both of these have been trained on ImageNet, which is a data set that has like 14 million different images. So we're taking the knowledge that was already, I guess, learned by these two models and applying that to a specific subset of that original problem. So in this case, we have Alexnet and SqueezeNet, which have seen 14 million images. So identifying bees and ants shouldn't take a terribly long time, right? If it can identify everything else, bees and ants is just a particular use case for it. And so we'll be using that for our validation. We'll be using those for our pre-trained models to see how they do. But that's really it for the code. Like, I don't want to get too deep into the weeds here because it's just another training script. Like, there's model stuff happening in here. But a couple of things I do want to point out. So y'all already know about initializing a DVC repo, and I want to share this. I don't know if everybody's familiar with checkpoints. So has anybody here worked with checkpoints before? I'm just curious.
Just saving the model weights, no? At every epoch, every stage, you just know the model weights.
Ah, gotcha.
Saving model parameters.
Yeah. So I'm kind of surprised that nobody's really used checkpoints, but that's really good to know. But basically with checkpoints, you're able to log the metrics for every training epoch instead of just the entire experiment. So that means you can see like where things might have went a little weird with training. Maybe you had some dip in the accuracy for some weird reason at a training epoch. So that is what checkpoints gives us. It's just more granular metrics. But the way that we add that is we actually need to add the DVC live library, and wherever you're tracking your metrics. So if you are doing training epochs, you're probably outputting the loss in accuracy to something, maybe a file somewhere. But with DVC live, if you just log those particular metrics, it creates the tracking file for you. So for example, you can see here, this results.json. This is from whenever the last time was that I ran this training script, and DVC live just automatically has that. And also something else that we'll get to take a look at a little later is a look at the plots. So DVC live also generates some plots for you to show you how your model is doing with each training epoch over time. But with that being said, let me check my params YAML, and looks like all of our hyperparameters are fine. We got the right class size. That I was working on a different blog post, and that threw me off for the longest time, because if you have more than 2 classes of images, you should have more than 2 classes, right? But anyways, so we're going to start with the Alexnet model, and I'm going to make my terminal bigger. Well, I'm already in my virtual environment, so that's nice. And before I run this, I'm going to take a look at my table to make sure it's all cleared out. Okay, we're good there. So now I'm going to run an experiment. And we actually have 5 training epochs. So this is going to take a little while. But while it's doing that, I do want to show you something here in the browser. So I have this DVC plot file open, and actually just ignore that for now. Let me get a training epic finished here. But I was wondering, are there any questions so far? Nothing in particular.
This Jason with the metrics that you were logging. Was that right? You kind of where you were logging things and you had one entry. Is that just because you've only run it once, or does it overwrite every time?
It overwrites every time.
Yeah. Okay.
So, but yeah, so there's actually kind of two parts to the DVC. If you're using DVC Live, you'll have each metric individually get saved to a TSV file that'll get appended with each epoch, and then this is kind of your summary that fits neatly into sort of what DVC expects. So you won't lose the information even if you. So with DVC, you could always, of course, go back in time and look at those previous checkpoints, but also even if you're not inside of DVC or something, you will have those TSV files that will show the epochs over time as well.
And then Dave, do we still need to do a DVC push to keep the metrics for checkpoints?
Yeah, well, the metrics themselves, if you're saving them in Git, will just get pushed with your Git push. So really, like the DVC push would only be needed for actually saving whatever you're caching in DVC, your model outputs or your data.
Okay.
Kitty.
Let's see if my plot has, oh, it has been over. Oh, it's updating right now because it's in between training epics. But that's one kind of cool thing, I think, at least, is that you get this live update with a graph as it goes through the training epics. As soon as this one finishes, because I'm sure y'all know that sometimes training just takes a while. But after this epic, I'm gonna go ahead and stop it so that we aren't just watching this the whole time. Okay. So I'm just gonna with out right there. This is what it looks like when we did 3 training epics. So you can see that with each one, the accuracy increased and the loss kept decreasing with time. So this is what we would expect to happen with training epics, right? But yeah, that's just one of the cool things that you can see with DVC Live. But now I want to switch back over here and let's take a look at that table. So yeah, this is a lot to look at. I'm gonna kind of clean it up a little bit and just show the hyperparameters that we're interested in. So I'll do, well, let me clear the terminal out so y'all can actually see what I'm typing. I'm gonna do DVC exp show. I'm not gonna include the timestamp anymore. And let's see which params to include. So I'm gonna include that was weird. I'll include the model name and I guess the learning rate and momentum, just so we have some stuff to look at. Okay, that's a lot easier to see now, but you can see here in this table that we have our training epic that starts at 0 and we go up to where we cut out at the 3rd epic, but the accuracy looks pretty good for Alexnet training with that B and ANT data. So now we've seen what it looks like with Alexnet. Let's go ahead and switch over to SqueezeNet. So few different ways we can do that, but I'm gonna go ahead and just do it in the terminal and I'll run DVC exp run. And I always forget if it's 1 dash with the big letter or 2, but I'm gonna try it with 1 dash right now. So we'll update this model name to SqueezeNet. Oh, sweet. I love it when I get the command in the terminal right the first time. But are there any questions about anything up to this point?
It's great to ask questions. You get bonus points.
True. Maybe you can have a DV one day.
Definitely.
But I guess the main thing that I'd like to know is, do y'all see the actual use case for using checkpoints? Like when you're going through experiments and looking at your own metrics or whatever it is you're using to compare models, would something like this be, I don't know, something that you're looking for or something you use pretty frequently?
Does it also actually checkpoint the weights itself as well, or is it just the like a storing of the metrics?
Yeah, it will checkpoint the model weights as well. So the idea is to kind of give you the full reproducibility that you would normally get with DVC, but without having to interrupt your code, right?
So every single step that you
That's
have,
right.
that is. Okay.
Yeah, you can control that as well. You don't have to save the model at every single step if that's going to make you run out of memory. You could do every 10th step or something like that.
Yeah.
Basically, you can control that in your code.
Any other questions?
I think this checkpoints feature prevents overfitting or underfitting. When you train the model, you can see which epoch your model starting underfitting or overfitting, and you can choose epoch size from these checkpoints.
Mhm.
And maybe I'll just throw one plug out there on top of what Milecia said, which is that I think we're still very much in sort of the experimental phase of how to best like utilize this checkpoints workflow and the best features to provide for people. So, if you are thinking, well, this seems nice, but it kind of, I kind of need it to work this way instead, let us know, or join in discussions on GitHub or Discord. We'd love to get your feedback on it.
For sure.
Yeah, I mean, I guess from my point of view, it seems to have utility. To be honest, though, I'm kind of a novice when it comes to deep learning. I don't use that a lot in my current role, and so I just haven't had to solve this exact problem yet. And I guess maybe I would also be curious, just in the little bit of tinkering I have done, how this functionality compares to what is natively supported in some of those deep learning frameworks like TensorFlow.
That makes sense.
Yeah. One thing that I think we're working on, like one reason that we're introducing this DVC live library is, even though we tend to try to stay out of the way of your code, is that like first of all, we kind of need some way to checkpoint within your code here, and then we also are trying to figure out how best to provide those integrations, like you said, just so that we're not kind of duplicating what TensorFlow would be doing, for example, but integrating and building on top of that. So it's like making it easier for users instead of having to make them do the same thing twice or learn a new way of doing it.
Mm-hmm. Cool. Yeah, I would definitely check it out if I had that your use case to work on. I just haven't I haven't been there recently. So, but I'll definitely probably be looking up the docs the next time I get a chance to work on something like that.
Cool.
It does seem really. I'm sort of I haven't quite got my head around everything that's happening. So it could be a use case, a solution to a problem that we were kind of solving, because we have these models. I mean, they literally take weeks to train, and so we just train it for loads and loads and loads of iterations, and we've built our kind of own functionality to do basically the kind of checkpointing in S3 and things, and then we subsequently go back and we run listening tests and find the best iteration to have chosen, and then that's what we then deploy. Now, so the kind of process which we've done so far to kind of simulate that, to kind of get that functionality in DVC, is we run the training for a very large amount of epochs, and that can just happen. And then we have a stage in the pipeline, which is basically choose iteration, and that becomes the one we find. And then we have the evaluation that goes after that. I mean, would this have been a much better, elegant, more solution to that problem? Is that something we could have used in this situation?
I want to say it's to an extent, yes, but I would also say we're still, like I said, it's still very experimental. So we're kind of like the last step of choosing the best. You know, you have your script to like choose the best checkpoint stuff. There are ways to do it today, but it's not as smooth as we'd like. And I don't know, I think we have David on here. I don't know if he's really spending a lot of time working through that and trying to solve those kind of issues. So yeah, that's where like getting more feedback and continuing to work through it would be helpful. So the goal is for it to be that, but I think, you know, we're still kind of, we haven't really documented that pattern that well yet.
Okay, cool. Yeah, because that's something
Chris,
we have to do a lot.
I assume that you were using something like Keras or something in order to save the model if it's at a minimum loss.
Well, so unfortunately in speech you can't, there isn't really a computable metric that we can use to say which model is better. We literally have to listen to them.
Right, yeah. So in that case, it seems like this sort of DVC live checkpoint thing is going to solve your problem. Things like Keras and TensorFlow, by default, they expect you to have some pre-computable metric, and yeah, they will only save the model based on that. This will give you a full history, so it sounds like it would have at least avoided some of the amount of work you seem to have to do. Yeah.
But would it be an easy place to put in a pipeline to then say that's the model which we ultimately chose?
Sure. I mean, you would have still had to write a little bit of code in order to do that, in order to basically process the checkpoints.
Yeah.
But sure, yeah.
Okay, cool.
Awesome.
Yeah, it's good to know that this is something that, I don't know, is actually useful to y'all. But I did let it run all 5 of the training epics. There's one probably pretty important thing that I forgot to do though. But first, I do want to show y'all what it looks like with 5 epics. Oh, no, I should show y'all my little snafu first. So the thing with checkpoints right now is that if you want to start a new experiment from scratch, you have to reset your checkpoints, or else DVC just continues training from the previous step. So that's actually what happened with our model here, because I didn't reset it. It just continued at step 3, which, I mean, it's not the end of the world, but not the greatest thing either. But that could have easily been prevented if I had run DVC exp run and used the reset flag. So I'm going to do this and change one of the hyperparameters just to show what that looks like when we do reset it. I'll set it to 0.5, and don't worry, I won't let it run for all 5 training epics this time. But the thing I want you to note here is when we did switch to the SqueezeNet model, it dropped in accuracy quite a bit, even though we were picking up from the last training epic. But just comparing these, it definitely looks like Alexnet is the better model to use for these bees and ants, because in 2 training epics, it had 88% accuracy. In 5 training epics, this one was 4% worse than Alexnet, which is fine. That's what we needed to see. Because if we look over here, this has all 7 of the training epics. Well, because that's 8 technically, because 0 is 1. but you can see where we had that huge change where we switched from Alexnet to SqueezeNet. But oh, it's updating right now with the new training epics with that new learning rate. So actually this does just update live as it finishes going through each step. But I think that was really the gist of what I wanted to show y'all today. This finished a lot faster than I expected it to. Did y'all have any questions about like checkpoints or epics in general? Because one important thing is when you are using checkpoints, when you write your dvc.yaml for your output, this will be where your model weights go, but also add this checkpoint true so that it's tracking all of those changes with each checkpoint as well. Because even though you have the DVC live library in here, DVC still needs to know that you're using checkpoints so it knows how to keep track of everything. And look, we have 2 epics finished, so it's just slowly changing these graphs, which is pretty cool. Did y'all have any other questions about anything?
Or any other things that you would like to see in this project
Yes.
or clarification?
Sorry, I'm pretty novice to this, but so you have Alexnet model and SqueezeNet. Are they in the same DVC project? So that's how you're getting them in the same experimental data set?
So Alexnet and SqueezeNet are actually coming from some PyTorch magic.
Oh, okay.
Yeah.
Okay, sorry.
Oh, you're fine.
In the blog post that I put in there, the links to those things are in there.
Awesome.
Yeah, and there's a link to the tutorial that this was based off of too.
Right.
But I don't know about y'all. PyTorch documentation is a little, it's a little rough.
And I just put some links to some research papers on this topic too.
Research is in the libraries or the?
These were on the transfer learning, right, Milecia?
Yeah.
Okay.
Just some academic papers on transfer learning because
fun reading.
Yeah, just some light reading.
Awesome.
But I guess since this is just finishing up, there's a few more epics that can run. We'll let that happen in the background. But I'll finish up the presentation real quick. Did anybody have a question or comment? Okay.
We're good.
So, oh, that's why we already went through everything. We did add DVC checkpoints and look at the metrics with Alexnet and SqueezeNet. Okay, so I didn't skip anything. There are a few little key tidbits that I hope you take away from today. So the first one is that transfer learning can speed up your model development a lot because you're already taking advantage of the knowledge, well, the weights for an existing model and just maybe updating the head or updating the last few layers of that particular model for yours. And then, of course, being able to reproduce your experiments gives you more of, I guess, peace of mind when you want to quickly just try out different things. Maybe you want to switch your models and see how they compare. Maybe you find out your data set needs to be cleaned, so you delete some images, or maybe you need to tune 20 of the 70 of your hyperparameters and you want to keep track of that. That's what DVC lets you do. It does data versioning, it keeps track of your experiment, like the model weights and the metrics for everything that you run. And I don't know, it's just pretty lightweight and easy to stick into any project. And yeah, that's pretty much what I just said. It makes metric comparisons a lot easier. So if I switch back over here to this plot, we have all the epics. This is what DVC made for us, just based on what we were already going to output from our model anyways. So you can see how things change over time. If you needed to show this as a report to somebody, you already have it there. It's not a lot you have to go through and kind of finagle with and clean up or do some kind of homespun thing. Like tools like this are there so that you don't have to do that hard part. So don't reinvent the wheel and just use DVC.
Cool. Any more questions?
No, I think this is great. I know the modelers I work with are rather lazy, so I'm surprised that a lot of times they just don't test certain things. So I want to run through the article, the blog post and stuff, and test it on my end and see how easy it is for us to get into our flow. But yeah, I mean, it looks. I mean, you're kind of hitting that one squeeze point where I have like lazy modelers that I work with and expecting certain things, and then you guys are putting it like just add the library, add this in. You're halfway on. You're 80% on the way. So looks great. I just haven't actually run through it. Sorry.
Cool. That's great.
Yeah, it does seem really good. I think we're just integrating the kind of initial parts of DVC into tracking our experiments and then getting things to deploy more easily. And I think I can definitely see how this would help. One question I did have, and I think it might be solved by kind of Studio. Again, I haven't really looked in I haven't fully got my head around exactly that, how we can use that. But this is showing us one run at the moment. And if I wanted to compare a variety of runs, how best would you recommend to do that?
Right now, this current table is showing 3 different experiments if you just wanted to do a quick glance, but I do think the Studio probably is the easiest way to look at the metrics across different commits, across different branches and things like that. Anybody on the team have another comment on that? Is DVC Studio pretty much the easiest way?
Yeah, I mean,
Go ahead.
No, go ahead, guys.
Well, I was just going to say you can also use DVC metrics, diff, and DVC plots and that sort of thing.
But yeah, I think Milecia, you covered it well. Like, I think the experiments table is kind of like the lightweight way to do it, or Studio would give you like a little nicer visualization of similar information, right? And a little more power to kind of filter out which experiments you want to see and things like that. Which there is some stuff in the table here that you can do to do that, but it's, obviously it takes a little more to like put flags in your CLI command than to just click things in the Studio interface. And for those who aren't familiar, Studio is like the web interface that has been introduced for on top of DVC to visualize and do different things with experiments. So.
I can show that off real quick. So yeah, this is not the same thing that we were doing experiments on. This is a different repo that I have set up. But basically, you can come in here and see how your accuracy and loss and hyperparameters and things change with each experiment. And if you wanted to compare across different branches or different commits, you can look in here and, well, I don't have plots data set up. So I'm actually going to come back in here and run DVC plots diff, and I'm going to compare this experiment from where SqueezeNet started from the Alexnet checkpoints, and this one where we reset the experiments, and SqueezeNet starts from scratch. So if I look, wait a second, plots, here we go. So if I drag this up here, you can see a direct comparison between those two experiments. So like this one, we only have the 5 training epochs, so that's why it stops there. And this one is all of the training epochs that we had because that old SqueezeNet experiment picked up from the Alexnet checkpoints. But yeah, this is another way that you could compare metrics to. And then if I make this a little bit bigger and get rid of plots and just show metrics, this is a quick way to look at the difference between an older experiment and a new experiment. It quickly lists out like the delta between each thing, and yeah, just a few different ways you can get more targeted metric data.
Of all the checkpointing. What it does is basically saves top 5 checkpoints, best checkpoints, and the last checkpoints. So we basically take top 5 and the last checkpoint and push it to DVC. For metrics and stuff, we use Neptune logger, which is exactly what has the same plot that you saw. Haven't explored your thing, but we have an alternative. PyTorch Lightning, and PyTorch Lightning, we can have a lot of hooks there. We can plug in whatever logging we want. A lot of supports for that. Maybe I'll give it a try.
Yeah.
Yes.
You should definitely give it a try. And if you have any problems with it, you can always ping us in the Discord channel.
Yeah.
Yeah, we'd love to see that. And if you have it, you can present it at the next office hours.
Basically, we don't use DVC much. We just use it for pushing and pulling data. We don't use it for our model training. Since we have very completed and integrated code base, we haven't brought DVC for training purposes. So I don't know much about DVC with respect to training. All I know about is pushing and pulling data.
Cool. Thanks for sharing. That's cool. Any other questions? What would you like to see more of from us at office hours or in the docs or in any other way?
Mostly for me, it's how do I make this contextualized for my environment, for my teams that I'm working with. So to be completely honest, a lot of the teams we're working with are not machine learning specific. Mm-hmm. So they're just looking at, simple, older type models. And we want to use DVC for the versioning and everything, all the, and the metrics pieces. It's just, how I'm trying to construct that in my head, how that actually applied, how best utilized for us, whereas it's not as much as the machine learning.
Yeah, we're definitely trying to work on a bunch of use cases. Right now we have the docs team is working on a use case so that we can start building out those type of stories that will be different for different people so that you can start to contextualize those things. Okay.
I'll set up, I see you shared your calendar, and maybe I'll block some time and I can give you a list.
That would be super. Yeah, I would love that. And that's open to anybody. We would love to learn more about your team, what it's like, what you're working on, what your challenges are, and what we can do to try to fix that for you with our tools. So I would love to hear from any of you and have a conversation anytime. So I put the link to my calendar in there. Cool.
Yeah, I'd say, Justin, if you want to, if you have a specific need that you want to discuss, well, or feel free to throw it out there now as well. Or you can try and say it, collect it all and we can discuss it another time. So either way is good.
Yeah, let me kind of box mine up into like some asks. And I'll also remember, I'm a product manager with our teams and such, so I'm not actually the modeler. So that's why a little bit this is also just me picking up things on this aspect. But let me structure that up, set up some time with Jennifer, and then we can go from there.
Sounds great.
Cool. Thank you. This looks really nice. I really like the DVC live aspect because I have been amazed at how lazy, not our modelers per se, but some modelers in the industry in general are very late. So I was just like shocked about that. So I think that's going right down the right alley.
Cool.
Actually, I want to say something that DVC Live checkpoints thing is not specifically feature for machine learning, right? You can use any Python project this feature. Also, I want to say
if you don't use DVC Live, you can directly use checkpoints by creating a checkpoint file. So you don't have to use Python either.
Okay.
Yeah,
so I just want to say
ahead,
that, sorry for interrupting. I just want to say that sometimes in the school, for example, we are taking biological class and DNA sequence projects or something like that, or we can apply to school projects this feature.
I recently saw some other article that somebody was writing about that they're using it in the gaming industry with that data. So they're not using it in the same way, but they're able to version their large files because it's the same with DVC. So we didn't even think of that. There's all kinds of, different use cases for it when things need to be versioned. So any more questions? Or I will close. And I have a puppy in here, sorry. So thanks to Milecia for the great talk today and for all of you in this really awesome discussion. A few announcements here at the end. At our next office hours meetup, it will be on October 14th. We will have two presenters. The first is Andreas Malekos from Continuum Industries, who will be presenting on his team's MLOps tool stack and where DVC and CML fit into that mix. And the second one will be Macon Schatz of Capco. He has created an internal Kaggle competition using DVC and CML in order to drive clarity amongst his team to improve their fraud detection algorithms. So this is really interesting. I thought that was a cool topic and a way to set up a team and to get your stuff done. So that should be pretty interesting. Also, we will be starting our next cohort of DVC Learn on October 6th. This is a set of 3 biweekly classes. It's designed to help you get up and running with DVC. Milecia will be teaching those sessions. So if you are new to DVC or know someone that is and would like to get your questions answered as well as meet other new learners, please come and share about those meetups. That would be great. So I put links to all of these things in the chat, which you said, as long as it's linked to the calendar. Please, in the meantime, visit us in Discord. You can always get your questions answered there every single day and participate in the community, and we would love to have you there. So that is all for today. Thanks everyone for being here, and we will see you next time. Have a great day.
Yeah.
And if you want to collect the things in the chat, you can use the ellipsis at the bottom of the chat to just download it all, because there was quite a bit of content in there today. Great to have you here, guys. Have a good one.
Thank you.
Thank you for making this event.
Thanks for being here, Merritt. Love your shirt.
Also, sure. Yeah, have a nice day.
You too.